Let me piece yourself back together now. What's your vision?
Our world exists in one universe, but contains another. A liquid wonder on the surface, dark and hostile below.
A human couldn't survive outside of this protective vehicle for more than a few seconds.
We are not welcome in the deep, but could not exist without this alien world.
Without that ocean, early life just wouldn't have ever have had a chance to get a foothold on this planet.
The ocean is our lifeblood. It regulates climate and sustains us. But as it gives, it also takes.
The force of the water is incredible.
When it sucked back out, just pulling the air right out of your lungs.
We didn't have any possibility of retreat or going forward.
This was bigger than I could fathom.
Unseen forces in the deep unleash destruction on land.
160,000 people died. They didn't interpret the signals.
There is no escape or survival
We don't understand the power of the sea.
until we fully explore Earth's last frontier to uncover the secrets of the underwater universe. Of all the known objects in the universe, only one is covered in liquid water: Earth. Just far enough away from the sun so it doesn't all evaporate. Just close enough so it doesn't all freeze. Scientists agree that there are about 326 million trillion gallons of water on Earth. But they disagree as to where the oceans came from. Some say water was delivered in the form of ice by comets. Others say that water was already present when the planet formed 4.5 billion years ago and gradually floated up to sit on the top of the rocky crust. What lies beneath the ocean's surface? A mysterious world, hostile and mostly off-limits to air-breathing humans.
You go a few miles down and you're a totally unfamiliar world. And by unfamiliar, I mean there are things there in the darkness and the remote parts of this planet that you can't even dream of.
If the water were suddenly to become transparent, allowing us to see into the darkness 3, 4, 5 miles down, we would see an undersea landscape perhaps more varied and violent than the one we live on. What happens here has a direct impact on the course of history. Since the origins of man, tiny humans have clung to the edge of a watery world, trying to survive and outwit forces immeasurably larger than us. Nothing epitomizes the extreme of these forces more than 7 deadly seas. 7 lethal locations where the ocean repeatedly demonstrates how easy it is to swamp us, sink us, drown us, and crush us. To better understand the dangers above, we must know more about what lies below. Exhibit 1. The first destination on the 7 deadly seas is the Java Trench. 1,600 miles long, it arcs south from Burma to Sumatra. If you could see 5 miles under the Andaman Sea, you'd see a deep canyon where 2 of the Earth's tectonic plates come together.
Most people would think the Grand Canyon was one of the greatest trenches on Earth, but actually any of the trenches in the oceans are much deeper and wider than the Grand Canyon would be.
Geological fault lines like this one are where tsunamis are born. Tsunami. Like a monster rising from the depths, the sea itself is suddenly set in motion on a scale that demonstrates how puny humans really are. Because we know so little about the underwater universe, tsunamis often strike without warning. Before December 26, 2004, no one knows or even cares much about the Java Trench. But at 3 o'clock that afternoon, it gets our attention. A sudden jolt from deep within the trench generates a massive submarine earthquake, 9.3 on the Richter scale. It's more powerful than all the quakes anywhere on Earth for the prior 5 years combined. Using an array of underwater microphones placed years earlier, scientists record the sound it creates in the abyss 25,000 feet down.
We recorded at very low frequencies, only up to 125 hertz, so we have to speed up the recording to make it audible to humans. But when you speed it up by 10 times, what it sounds like is basically a very low, eerie rumble.
What you are hearing is the sound of energy being transferred from a shifting sea floor to the earth and sea around it. The power unleashed has been calculated to equal 600 million Hiroshima atom bombs.
And by using that sound, we were able to basically map the whole rupture length and the speed at which it ruptured.
The rupture lasts more than 8 minutes, ripping its way along an 1,100-mile stretch of the Java Trench, about the length of California and Oregon combined.
All unzips all at once. A lot of water suddenly gets pushed up and down. On the side of Sumatra, Malaysia, Thailand, the seafloor moves down. On the other side, the seafloor moves up.
The earthquake pulls the water down 2 feet, then bounces it back up 4 feet. A chain reaction starts. They're called gravity waves, and they spread in all directions. Like ripples in a pond, but on a global scale. The tsunami waves are 300 miles apart from the crest to crest. Scientists at the National Oceanic and Atmospheric Administration have developed a tool to better visualize the global oceans. They have wrapped satellite images around a 3-dimensional sphere.
Red and yellow indicate peaks, and green indicate troughs. The tsunami moves at an incredible rate. It's the fastest physical phenomenon we know, as fast as a commercial jet. The reason it moves so fast is because it's not moving water, it's moving energy.
Just like sports fans doing the wave, the energy is passed from person to person, circling the stadium faster than any human could run. So it is with the tsunami wave.
It's basically the sound traveling through the water, so it's molecules compressing and expanding next to each other. It travels a little less than a mile per second.
One of the places hit worst is 381 miles east of the Java Trench, the spectacular beaches of Thailand. It's the day after Christmas, 2004.
So this is basically where we were staying. It was a series of thatched hutches. It was on a small island called Koh Lanta, south of Phuket on the Andaman Sea. The day of the tsunami was one of the most crystal clear, beautiful days you could imagine.
At about 4:30 in the afternoon, Susan McClure and her 2 daughters are relaxing by the beach. Her husband is offshore on a diving excursion. The tsunami reaches him first.
That thing is whipping across the ocean. But if you were on a ship in the middle of the ocean and one passed by you, you'd hardly see it at all, because the amplitude's not very much at all. It's just a tiny little ripple that goes zipping by you 500 miles an hour.
In deep water, the wave is only about 30 inches high. But this ripple of power extends down to the depths, where divers feel it surge like a riptide.
The current actually lifted them up and brought them back down.
A diver would probably have heard the sound of the earthquake happening, and in addition, they feel the lower frequencies actually pulse your body.
The first wave roars past the divers toward the beach. As it gets into shallower depths, it slows down. That incredible ripple of energy is now concentrated into less space. Water stacks up on top of itself and gets taller, 8, 9 feet and rising. Just in front of this towering wave is an equally oversized trough. The leading edge is what's called a negative or depression wave. It empties the harbor of water.
When you're at the beach, you observe the waves come in and then they go out, and they come in and they go out. Well, the tsunami is just an exaggerated wave of that nature. And this time, instead of a wave coming ashore every 6 seconds, it's coming ashore every 15 minutes.
Home videos from Koh Lanta reveal that people on the beach are mystified. Then they see it. The wave's leading edge approaching from the distance. Almost 15 feet high. What they can't see is that behind that looming wall of water, the entire sea level is elevated. Susan McClure is lounging in a hammock.
I might have seen somebody running. I really can't tell you what happened and why I stood up. But I did, fortunately, and I saw this incredible wave coming. It was so big, and it took a long time to realize what it was. It was the most interesting thing you'd ever seen. You couldn't not look at it. And there was a boat about 300 feet or so from us, and it just smashed it. It was the sound of things popping and breaking, the sound of bamboo, and it just shatters. I kept yelling for my kids. I just kept screaming for them to run, but there's no way they could have even heard me. It was so loud.
The first of the 7 deadly seas, the Andaman Sea. On December 26, 2004, a shock wave ripples up from 5 miles beneath the surface. It grows 130 feet high in some harbors and rushes inland as much as 3 miles, taking with it everything it can.
The force of the water is incredible. Water is 1,000 times heavier than air. So being in a 10-mile-per-hour water current will have approximately the force as being on a 10,000-mile-per-hour wind. You simply cannot stand.
If the tsunami were only made of water, that would be bad enough. Unfortunately, this wave brings sand and rocks up from the underwater universe and hurls them onto the beach. Each mile of shoreline is slammed by 33 million cubic feet of water and debris. It's as if Thailand's western shoreline is hit by a tide of wet cement the size of the Great Wall of China. People who stay to see the wave do not survive. Those who run away are unsure what happened. Fortunately, Susan McClure finds her children, and together they scramble to shelter.
We had no idea what could have possibly caused it, or how long we should wait, or what was the next episode.
Desperate for news of her husband's whereabouts, Susan returns to the beach and finds devastation.
It was an incredible shock to realize that something that had been there just moments ago could be so completely and totally destroyed.
Susan doesn't realize just how dangerous her location is.
That took us all the way down to the south part of the island.
Her vacation bungalow is tucked away in an idyllic bay. But scientists at the University of Southern California's Tsunami Research Center have learned that this is the worst sort of place to be when a tsunami strikes. A model reservoir on top of a shake table shows why.
That will generate some wind waves in the basin. The waves are very, very small, they're ripples. The wind is putting energy only on the surface of the water.
But a tsunami wave is very different from a wind-generated wave. The flat sides of the square tank are like beaches, but the corners are like harbors. They may be protected from wind-driven waves, but they funnel the tsunami inland.
And I will put my finger at where the shoreline was before we started. It was right about here. As you can see here, it's exactly the wrong place to be in the tsunami.
For Susan McClure and her daughters, their ordeal has only just begun.
And then all of a sudden people start screaming again because they feel that another wave is coming. And it was just like one of those horror movies where everybody's running at you and they're all screaming.
Susan and her children run for high ground again. A second wave hits the beach, then a third at 15-minute intervals.
Each wave actually organizes the debris that it created from the previous wave. So it becomes more like a bulldozer. And then the third wave organizes even more material, and it becomes a better, more effective bulldozer.
Buildings, animals, and people caught in these later waves are literally pounded and ripped to shreds.
It's just like being in a concrete mixer, that you have nails and large pieces of cement, all of it being tumbled around. So there is very little chance of survival.
Dying in a tsunami is a violent activity. You're traumatized by either broken bones or crushed rib cages or just sheer weight of this.
After 3 agonizing hours, the sun sets on a scene of unparalleled devastation. The most destructive tsunami in modern history.
It's getting dark. There's still no sign of Bill.
Last Susan knew, her husband was on a dive boat offshore. The McClures are among millions of survivors all around the Indian Ocean who are wondering whether their loved ones survived. Victims are spread across 5,000 miles of coastline in 11 countries.
We can see the tsunami continuing to spread out across the planet. Not only was the tsunami so powerful that the waves reached the east and the west coast of the USA, but it also shows us there are not discrete oceans. There is one body of water, one ocean. They're all connected.
I was sitting on my towel with each of my daughters, realizing that this is it. We're gonna be here for the night, and that we might as well try to get as calm as we can. And my husband walks into the light, and I see him standing there looking for us. And I turn around, and 150 people start clapping. They're all got tears running down their eyes, and it was a really wonderful moment to be reunited.
Not all are so lucky. Over 220,000 people die in the tsunami. No part of the planet is unaffected by this massive surge from the underwater universe.
We don't understand nature as well as we think we do. And by studying the underwater world, we're never again going to be as surprised as we were that day in December 2004.
Tsunamis demonstrate the unstoppable, unforgiving power of the ocean. But they are relatively rare. There are places on Earth, however, where the brutality of the churning waters is constant. The second of our 7 deadly seas is between the southern tip of South America and Antarctica. the most violent stretch of water on Earth.
It's just an incredible place on this planet where the winds just whip routinely 60, 70 miles an hour and more.
About 1 day in every 5, the waters off of Cape Horn can be seen sinking and rising up an average of 60 feet high, as tall as a 6-story building. A 60-foot wave can rock and roll even the largest ship. No man-made craft is safe here when a storm passes through.
It's basically just luck of the draw. You never know what the weather's going to be. You can't predict it that far out when you're doing a voyage around Cape Horn.
In late October 1990, 2 veteran sailors, Steve Pettingill and Rich Wilson, set out from San Francisco in a 60-foot-long trimaran, one of the world's most high-tech racing boats. They leave port with hopes of breaking a speed record for rounding Cape Horn under sail power. What they get is a view that few have lived to describe. A close-up look at the awesome power of the world's angriest ocean. During the California gold rush of the mid-19th century, clipper ships routinely braved the treacherous trip around South America between San Francisco and Boston because it's faster than going across country.
They were racing against time because time was money. The sooner they could turn around a load and go back, the more money they made.
The speed record for this 15,000-mile voyage is 76 days and 6 hours, set in 1853. Just over 3 weeks into their voyage, Pettingill and his partner are 3 days ahead of schedule, well on track to breaking the speed record. Then the trimaran turns east and begins the approach toward the narrow stretch of ocean between Cape Horn and Antarctica.
One of the problems with Cape Horn is currents are so strong and it doesn't take long for it to build up really tall seas.
Pettingill and Wilson are being propelled eastward by the world's largest and strongest current, the Antarctic Circumpolar Current, or ACC. Satellite images of the South Pole give a clue as to why the ACC is one of the world's deadliest currents.
If we bring Antarctica up, you can see that it's the only place on the planet where water can move around unimpeded. There are no land masses to block the passage of the water.
The current chugs around Antarctica at only 2¼ miles per hour or less. Not very fast, about the speed of a man taking a stroll. But this current is like a freight train in low gear, massive and unstoppable. It carries 130 million tons of water per second towards Cape Horn.
It's hard to comprehend how much water it is. If you took all the freshwater rivers, so the Amazon, the Nile, all these large rivers, put them all together, the amount of water through those rivers per second, multiply that times 150, and that's equivalent to what the ACC is. It's a magnitude that we're not quite used to.
The Antarctic Circumpolar Current is not only huge in volume, but highly turbulent on the surface. There are 3 factors that combine to create high seas: wind velocity, plus the duration of the wind, plus distance, equals big waves.
The thing that builds up the wave height and the current speed is the amount of uninterrupted distance where the wind can blow. It's like the idea that if I'm pushing something, the longer I have to push it, the faster I can get it going.
These continuous winds blow the circumpolar current around Antarctica, making it a very dangerous place to be.
But as Steve Pettingill and Rich Wilson approach the narrow channel south of Cape Horn, they encounter an added element of unpredictability.
It wasn't so much the waves and the wind that started to be the problem. It was the waves coming from a different direction every couple hours.
The prevailing waves are 60 feet high from the west. Then a monster rolls in from the south, much taller than the others.
You could hear this thing roaring at you. It sounded like a freight train kind of gonna run you over. That's what flipped the boat up on its axis and on over. And I just walked up the side of the wall and up onto the ceiling and made the remark, Richie, I think it's over for us on this trip. It ain't like the storm stopped. It was still raging and the waves were just pouring over top of the boat. And you have like a wave the size of a 5-story building coming behind you. It gets to wear on you after a while. As we talked and worked out our strategy, what was the next move, you could hear this large roar coming. There's another large wave that actually grabbed the boat, flipped it back upright. And when it came upright, you could hear stains breaking and popping, chain plates going, the mast broken a couple of pieces. I knew the boat could stay upside down, that was good. I was good with that, but when it came back upright, I thought, holy crap, this ain't good. And when it fills up with water in less than 2 minutes, neck deep, 38-degree water, I said, this could be the big one.
November 22nd, 1990. When two men try to break a 140-year-old speed record around the tip of South America, rogue waves toss their 60-foot boat like a baby's toy in a tub full of freezing water. First, an 80-foot wave flips their boat upside down. In a strange way, bobbing just under the waves is more peaceful than riding on top of them.
It was a lot quieter. You didn't have the wind whistling through the rigging. You didn't have the seas raging as much. Now they're just going over top of you.
But then another wave puts it upright again.
That's holy crap, this ain't good.
This satellite image shows the place where the trimaran flips over. It is the narrowest part of the Antarctic circumpolar current, with only about 600 miles between the Andes Mountains to the north and the Antarctic Peninsula to the south.
So this huge body of water is making its way around the pole, and it reaches this pinch point between South America and Antarctica. The water is forced through this passage, gathers velocity, and the wind continues to blow and churns up the surface water.
If you could somehow look beneath the waves, you'd see that the powerful current has to cross over an undersea mountain range, a geological remnant from 23 million years ago when South America and Antarctica were connected. This choke point squeezes the Antarctic circumpolar current from below and from both sides. 130 million tons of water per second are compressed into a chaotic torrent. It's like water being forced through a fire hose.
The passage is constricting the ACC, somewhat like a nozzle constricts the fire hose. It's focusing all that water through that one little hole, and it's going to come out much more focused. It's going to come out much more powerfully.
Recent research suggests an even better metaphor. It's not just one fire hose, it's many fire hoses merged into one.
It's actually a system of currents. It's made up of a lot of smaller streams, a lot of filaments of water. The fewest would be in Drake Passage, where all of a sudden these 10 filaments of water have nowhere to go but through this small opening.
Add to this frequent storms passing through, with winds pushing waves in different directions. These confused seas make for waves like the ones that flip the trimaran. Pettingill and Wilson spend 4 excruciating hours in 35-degree water before their prayers are answered. Crewmen on a cargo ship caught in the same storm spot them, and the 2 sailors are finally snatched from the high seas. During the harrowing rescue, Steve Pettingill manages to grab his waterproof camera.
I've got some pictures from that little 35mm camera. You see that the containers on the back of the ship were smashed in. Some of the containers, even too high on the aft deck, had the top stowed in. This ship weighed 44,000 tons, and it was getting kicked around. I mean, it's unbelievable.
Even the largest ships that humans can make are like playthings when they venture out onto the unpredictable ocean.
I mean, you gotta really have yourself pretty sorted out to go around Cape Horn. It's not one of these things where if somebody should just say, hey, I would like to go see Cape Horn. My suggestion is buy a postcard.
Most sailors know the risk. But what is harder to understand is that the underwater universe can also reach up to do its dirty work in the air and on dry land.
There's nothing that happens in that underwater universe that doesn't impact something that happens on land. And conversely, there's nothing that happens on land that at some point doesn't come back and impact that underwater universe.
This is the third of the ocean's 7 deadly seas. Most of us think of a hurricane as being made of wind. But the destructive force also comes from the ocean. Hurricane Alley is where tropical winds arrive from the east, warmed by the African sun.
All the planet is trying to do is cool down. The sun's beaten down on the sands of the Sahara, beaten down on the tropical ocean water. So there's a lot of heat down there. The Earth wants to get that, cool down. Best way to do that, send it up north where it's cold. Now, you can do that a couple ways. You can put it in the ocean and send it up by currents. Currents, though, move very slowly. And the other way to do it is through the atmosphere. The neat part about hurricanes is that they are literally picking up huge amounts of water and heat from the ocean and then carrying it in these swirling bundles up to the north really quickly.
When these swirling bundles of heat and humidity strike land, dumping water where people live, disaster almost always follows.
I'm a meteorologist at the NOAA Hurricane Research Division in Miami. And basically our job is to figure out what makes a hurricane tick. Why do they go where they go? And why do they get as strong as they get?
One of the most destructive hurricanes to ever hit the United States is Katrina in 2005. She makes her first landfall near Miami, Florida on August 25th, with more than 16 inches of rain and sustained winds of 75 miles per hour.
The eye wall of the storm, the most intense part of the storm, was actually over my house for a few hours. I'd say we were a little bit underprepared.
Jason Dunyan and his fellow storm trackers closely monitor Katrina as she leaves Miami, crosses Florida, and then passes into the Gulf of Mexico. They predict the storm will soon veer north toward the coasts of Louisiana and Mississippi, home to 500,000 people. What they don't know is exactly how powerful Katrina will become. A storm will intensify if it can find enough high-octane fuel.
You know, warm ocean waters, you can almost think of it as the gasoline for the hurricane.
The surface temperature of the Caribbean Sea is often 80 degrees or higher. The hurricane sucks up moist tropical heat from the surface. Wind speed begins to increase as cooler air rushes in underneath the rising warm air. Those incoming winds bring in more moisture, which sustains the cycle and intensifies the storm. The only way to stop it is with cold water. A storm usually churns colder water up from the depths. This cools down the surface water. The hurricane runs out of fuel and dies. But something strange happens with Katrina. There is no cold water under the surface to slow her down. It turns out that Katrina has crossed paths with a deadly phenomenon deep beneath the waves, something called a warm core ring.
When we talk about warm core rings, we're actually talking about warm water not only at the surface, but it could be 50, 100, 150 feet down into the ocean.
These deep reservoirs of hurricane fuel are carried north from the equator by the Gulf Stream.
As the Gulf Stream passes through the Gulf of Mexico, it turns a corner. Occasionally, it pinches off a large, warm, deep eddy called a warm core ring.
These warm core rings are a lot like the swirling eddies that come off a canoe paddle as it slices through water. A rotating vortex drifting freely until it spins itself out. This drifting warm core ring is a massive vortex of thermal energy. When it encounters a hurricane, it acts much like the combustible chemicals on a match head.
this flame reaches the end, you can think of the hurricane suddenly reaches that extra energy that it needs, and then it flares up. When we go from maybe a Category 1 hurricane to what we see now, this could be a Category 5 hurricane.
Katrina's path coincides with not one, but two warm core rings. Hurricane researchers drop instruments into the heart of Katrina to measure wind speed. The results are alarming.
These winds were up near about 170 miles per hour, gusting to at least 200 miles per hour.
Katrina is already the 6th strongest hurricane ever recorded in the Atlantic. She has picked up 425 trillion gallons of water from Hurricane Alley.
You can almost imagine this storm moving north towards Louisiana, pushing this wall of water.
In Biloxi, Mississippi, there is calm before the storm. Ronald Baker, a 4th-generation shrimp fisherman, moves his boat to what he thinks is a safe bayou 3 miles inland, just like he always does when a hurricane is on its way.
Basically, we put the bow on the beach like we are here now on the bank, and then we'll go and find a big tree up in the woods that's nice and strong, then we'll tie to it. And more or less it's a waiting situation, you know, to see just how bad it's going to be.
You can see this water coming up here right now, and it is coming up quickly. I'm not going to stay here much longer, folks, because in fact, we need to back up now, Greg.
The ocean was roiling. 55-foot waves were measured by one of our buoys, which is the highest we've ever recorded in the Gulf of Mexico. This is when the storm surge is really starting to get built up.
As you can see, the waves are just crashing up here.
We have a Category 5 hurricane. We have a huge wind field.
The water is on the rise.
We can see this is really a disaster in the making.
This is Hurricane Alley in the Caribbean Sea, the 3rd of Earth's 7 deadly seas, each highlighting another aspect of man's fragile existence on a planet covered with water. Here, where the energy of warm waters escapes to the wind, a monster named Katrina makes its way toward the coast.
Ahead of the storm, the winds are pushing water, but also you have this low pressure suction that's pulling water up to it, so you're actually pulling water towards land.
The underwater universe is rising up in a wall of water as it gets closer to shore. Meanwhile, Ronald Baker is in Biloxi, Mississippi. He has found what he thinks will be a safe haven for his boat.
The water come up gradually at first, and then boom, and all of a sudden it was up all at once.
The devastating thing about hurricanes is not the wind so much as it is the water. Wind is bad, and wind does things like wiggle stop signs and blows the roofs off. But that water, when it hits the storm surge, is impressive. You know, water weighs, what, about 64 pounds per cubic foot. So if that much water is a 64-pound hammer, a wave that's 10 feet high, that's a lot of force. So when that stuff comes rushing onto land, it leaves an incredible wake of destruction in its path.
Katrina's storm surge hits 22 feet in Biloxi, reaching the top of the tree where Ronald Baker tied his boat.
We saw people's furniture, fiberglass shower stall, we saw it go by. Even saw a wedding picture float by. We watched the people around us. They was trying to salvage their belongings and do the best they could. And it just happened so quick they couldn't do nothing, really.
Baker's boat is slightly damaged, but his home, 1.5 miles from shore, is totally destroyed.
Oh, Lord, it was just almost like a bomb come in, you know.
Places like Biloxi, Mississippi were in that area where the maximum storm surge was really getting pushed up onto the lands. The terrain is so flat, and it's flat for miles inland, that a storm surge can really inundate a coastal area like that dramatically.
By the time Katrina's floodwaters start to recede 7 days later, she has racked up $81 billion worth of damage and killed more than 1,800 people. Ron Baker has seen his fair share of hurricanes, but even he was shaken by Katrina.
I mean, my grandparents never seen anything like Katrina. Like, I don't know what it is about the storms. It looks like they just, they get more aggressive, I guess you would call it. And it's just scary, it really is.
Like a tsunami, this is the 7 deadly seas at their worst. A case of the underwater universe rising up on land into our homes where it doesn't belong. But what happens when we venture where we don't belong and try to enter its realm? Far beneath the waves, the crushing power of the underwater universe can be instant and final for human explorers.
We've only explored about 3% of what's out there in the ocean, and yet we find all these incredible things. And so the question you have to ask yourself is that what's in that other 97%?
The fourth of the 7 deadly seas is the Philippine Sea, south of Japan and east of Guam. The most hostile environment on our entire planet can be found here, the deepest spot in the ocean. If you could take away the Pacific Ocean, you'd see a gash in the Earth's crust almost 1,600 miles long, 43 miles wide, and up to 7 miles deep. As far below sea level as the ground below a commercial jet. This is called Challenger Deep, Earth's deepest abyss. It lies underneath 36,000 feet of water. The weight of that much water creates incredible pressure at the bottom.
A human couldn't survive outside of this protective vehicle for more than a few seconds.
Only once have humans attempted to visit this zone of death. 1960, a year before Alan Shepard became the first American to fly up and out of our atmosphere. 2 other explorers, 28-year-old Navy Lieutenant Don Walsh and Swiss engineer Jacques Piccard, head in the opposite direction, straight down. Their destination? Someplace even more dangerous than space, Challenger Deep. Their craft is a 6.5-foot diameter steel sphere attached to the bottom of a 50-foot tank. It's a bathyscaphe, kind of like a balloon, but made to float in water, not air. It's called Trieste.
Imagine you take a steel cannonball and hollow out the middle, and then you crouch inside that with little portholes to look out of.
2 windows, one in the main compartment and one in the rear entrance hatch, will provide a rare glimpse at the undersea world, but they are also a structural weak point. The 2 explorers are a few hours away from learning just how unforgiving the underwater universe can be at 36,000 feet down. The oceans are vast and violent, easily able to destroy our cities and overwhelm our attempts to navigate their waters. Here in the Philippine Sea, the 4th of the 7 deadly seas, humans are getting ready to travel to their most crushing depths, Earth's deepest abyss, a place called Challenger Deep. For 28-year-old Navy Lieutenant Don Walsh, it is the ultimate challenge.
There are only 2 deep submersibles in the world at this time. The depth record of those days was 12,500 feet, which was set by the French Navy in the second bathyscaphe that was built. So when they start talking about going to 36,000 feet, it became a bit awesome.
The Trieste carries 9 tons of steel shot to make her sink to the bottom. This ballast will be unloaded when they need to float back up to the surface. The balloon-like tank above the crew compartment is filled with gasoline, not for fuel, but to provide flotation. Gasoline is lighter than water.
This has to be filled with a lighter than water substance. We can't use a gas like helium or hydrogen because it can be compressed very quickly with a moderate amount of pressure in the ocean.
At sea level, we have the weight of the Earth's air supply pressing down on us. Normal pressure like this is said to equal 1 standard atmosphere. But water is 1,000 times heavier than air. 7 miles down at the bottom of Challenger Deep, the water crushes in at 8 tons of pressure per square inch. To get an idea of the forces involved, imagine a Mack truck on top of a hamburger. A human wouldn't last a second. Astronauts don't have to deal with this kind of violence. A flimsy spacesuit is enough to protect them from the vacuum of space. But for the crew of the Trieste, even solid steel may not be strong enough.
If you let the pressure change a tiny fraction, you'd be dead. The machine has to take 100% of that pressure.
If all goes well, their mission into the depths will take 8 hours. They begin their journey in the epipelagic zone, the ocean's top layer. It's only 650 feet deep, the top 2% of the ocean. It's the brightest part of the sea, the most turbulent, and the most full of life. Below 650 feet, the Trieste passes into the mesopelagic zone.
We maintained evidence of some light penetration, maybe down to 1,000 feet.
But even in this fading twilight, there is plenty to see.
If you turn on lights, you'll see a lot of, it looks like dust in the water, but these are critters, plankton. As you get deeper in the ocean, then you get into bioluminescence, where a lot of these critters have their own light organs.
These animals have evolved an ability to see and be seen in a world of perpetual night. An internal chemical reaction releases a faint glow capable of attracting a mate or a meal. At 3,200 feet, the Trieste and her crew pass into the bathypelagic zone, the midnight zone. Animals become scarce.
You're looking at 10 or 15 feet out there, and that's about it.
The darkness of the deep is one of the major roadblocks to ocean exploration. We humans have never liked what we can't see. And yet 90% of the Trieste voyage to Challenger Deep is still to come. There is a world of monstrous creatures in the 6 miles of darkness below.
It's full of strange animals. And unlike when you go in the forest, they don't flee, kind of come up and look at you.
Oh my God! It's coming right at the ROS here.
The bizarre animals in this zone thrive at pressures that could crush humans to a pulp.
These animals are definitely well adapted to being under high pressure, those that have cavities that are filled with fluids. A lot of times people will ask the question, what happens when you bring up these animals from the bottom of the ocean? Do they explode? Do they implode? They actually are able to withstand the changes in pressure pretty well.
The Trieste, of course, is filled with air.
Even a tiny hole in our main pressure hull or a small failure around the window would have been absolutely fatal and instantaneous.
For an example of the worst that can happen, look no further than the USS Thresher, a nuclear attack sub built to dive deeper than any of her predecessors. But on April 10th, 1963, a problem causes her to sink below her intended maximum depth of 1,800 feet. Somewhere in the darkness, the Thresher's hull is crushed, like an eggshell, instantly taking the lives of 129 men. Crumpled pieces of the Thresher are eventually found scattered over the ocean floor, 8,400 feet down. The Trieste is well below that depth now. At 13,000 feet, she enters the abyssopelagic zone. It is a realm more hostile to man than the surface of Mars, yet it covers 56% of our own planet. It is Earth's primary environment, but only a few humans have risked all to come this deep.
There's something in human genes which drives you to explore. The sense that you're seeing a piece of the planet that no one's seen before. You know, that gets to you.
The bottom zone begins at 20,000 feet, almost 4 miles down. The two men inside the Trieste are the first humans to enter this zone. It's called the Hadal Pelagic, from the Greek word Hades, which means hell. As they look at the darkness through their plexiglass window, over 8 tons per square inch of pressure is pushing back at them. The only sound is their own breathing. Then they hear the one sound they dread the most.
There was this huge bang, a real bang. We didn't know what it was.
The Philippine Sea, the fourth of the Earth's 7 deadly seas. It is 1960, and 2 men are almost 4 miles down on their descent to the deepest place on Earth, Challenger Deep.
There was this huge bang, a real bang, and we looked around and we couldn't see anything obviously wrong.
Don Walsh and Jacques Piccard are not the type of men to be scared off by a loud noise.
So we decided to proceed ahead with the last 16,000 feet of the dive.
What they don't realize is that the structural integrity of their submersible has been weakened, even as the pressure outside squeezes harder and harder. Every foot they fall is another record. 8,000, 9,000, 10,000 feet deeper than any human has gone before. 5 hours after leaving the surface, they are finally approaching bottom, 36,000 feet down. Scientists have only theorized about what they will find. They expect emptiness.
You can see a reflection from the seafloor, and just before we landed, we saw a flatfish, like a small halibut. That was important because that type of fish is being a fairly high order marine vertebrate, not an invertebrate, shrimps and jellyfish, so on. Those were expected.
In a single glimpse, the crew of the Trieste has rewritten the biology textbooks. Scientists now know that strange creatures not only survive at great depths, but thrive in great variety. Once on the bottom, as they wait for the clouds of sediment to settle, they turn on an external lamp.
And then I could see this small crack on that rear window that was on the back of the entrance tube.
The loud bang they heard was the 6-inch plexiglass cracking. The two explorers, unsure how long their craft can survive, examine their surroundings. Unfortunately, the view is clouded.
It was like being a bowl of milk.
There is so little turbulence down here that the silt they stirred up on landing refuses to settle.
Nothing was moving. So after 20 minutes, we figured that we just didn't have that much time to spend down there if we were going to get back topside.
They have no choice. They must begin their ascent. It is a long 3.5 hours before they reach the surface. No manned vehicle has been back to Challenger Deep since that one trip in 1960. It is simply too risky.
The unexplored territory under the oceans equals all of our land mass, plus the moon, plus Mars combined. The next frontier is to start exploring and using this other 2/3 of the planet.
The technical challenges of manned exploration are enormous.
We can bear in mind, this design was locked in.
But some visionaries say trips to the ocean floor will eventually become commonplace. Maneuvering through such depths, instead of simply going up and down, requires a new generation of dive craft, as different from the Trieste as an airplane is from a balloon. So says veteran submarine designer Graham Hawkes.
We need to build things that look like aircraft.
Hawk's deep flight vehicles are made out of carbon fiber that can withstand millions of pounds of pressure. Lightweight and streamlined, they fly through the depths like a fish.
If you look at a manta ray, you see a flying machine.
This is a prototype of the ultimate submersible, Deep Flight Challenger. Someday soon, Graham Hawks hopes it will be able to fly 7 miles down to Earth's last frontier, Challenger Deep. But until that time, the ocean depths will remain the deadliest spot in the underwater universe. The ocean floor might seem like an alien moonscape filled only with strange creatures and eerie silence. Yet incredible mayhem occurs here on a regular basis, the result of geological forces deep in our planet's molten interior.
The oceans are anything but dormant. The ocean floor is probably the most dynamic place on the planet. Earthquakes and volcanoes constantly erupting at all different depths.
The fifth of the ocean's 7 deadly seas is on the other side of the planet, the Aegean Sea, between Greece and Turkey. Underneath the surface is a 200-mile trench. Here, fire meets water, with devastating results. Today, volcanic islands in the Aegean are a popular tourist destination. But this place has seen unimaginable violence.
Along the South Aegean Arc, there are volcanoes forming all the time. It's like a volcano nursery. And this part of the Mediterranean has a notorious history.
3,600 years ago, the island of Santorini is a center for maritime trade throughout the known world. The culture that thrives here, known as Minoan, is the most sophisticated of its day, with unique art, architecture, and sports.
The volcanic ash has preserved some of the murals, and the story that we can get out of the murals and the jewelry is this civilization based on love of life, music, birds, happiness.
For 1,000 years, the sea gives these people their livelihood, until one day, it takes their lives. 3 million years ago, there is no Santorini. There are only 2 sections of the Earth's crust colliding in slow motion underwater.
One plate is diving under the other plate and being subducted. And as the underwriting plate goes down into the mantle, it starts to melt, and blobs of that melting plate rise up and break through the crust above it and form volcanoes.
We are very familiar with explosive volcanic eruptions into the atmosphere. But volcanoes deep in the underwater universe are much harder to see. Before 2004, no one had witnessed an actual submarine volcano in its act of violence. But in that year, oceanographers from NOAA sent a camera 1,700 feet down to an underwater mountain named NW Rota 1 in the Eastern Pacific.
Suddenly, there was a huge burst of hot, cloudy water coming out of this pit. It took us a minute to realize what was going on and that this was actually some kind of eruptive activity.
The images that come up from the abyss are stunning and unprecedented.
Nobody had ever really seen an active deep water eruption before. As things continued to evolve, we actually saw lava come out of the seafloor, and at that point it got pretty violent.
Oh my gosh.
There were explosions and rocks flying through the water.
Before it became an island, Santorini might have looked something like this. Poisonous gas bursts, 750-degree water, and lava flowing out of the sea floor. With temperatures of 1,300 to 2,200 degrees Fahrenheit, lava is hot enough to turn most metals into liquid. But as this searing hot lava interacts with water, it quickly cools and solidifies.
When you have volcanic lava that freezes quickly, it actually turns into glass. It's an incredible thing to actually see. It looks like everything's covered in plastic.
Volcanic rock accumulates around the vent. Over time, it forms a cone. Lava also spills out of fractures on the sides of the underwater mountain and hardens into bizarre shapes. Over the course of 2 million years, volcanic rock continues to pile up on the floor of the Aegean. Eventually, the mountain rises 2,000 feet up, growing to 4 times the size of San Francisco. The inside of this mountain is a hollow chamber full of magma, waiting to blow.
You can suddenly get a catastrophic explosion and empty out the entire contents of the magma chamber, which is what happened on Santorini.
When the chamber is empty of magma, the top of the mountain collapses and the sea rushes in. What is left is a ring-shaped island with a narrow entrance into a well-protected harbor. For about 200,000 years, all is peaceful. In 4000 BC, sailors find this beautiful island and start to live here. By the start of the Bronze Age, 1,000 years later, they have turned the underwater volcanic caldera into an important seaport.
Santorini was the main trading center of the Eastern Mediterranean, or of the world for that matter.
But 1,200 feet below the bustling harbor, incredible forces are gathering once again. These people have built their seaport atop a massive time bomb. The 5th deadly sea, the Aegean Sea. A place where geological power meets the power of the ocean, creating a deadly combination. 3,600 years ago, subterranean forces gather strength. Enormous pressure builds under the flourishing seaport of Santorini, an island colony of the Minoan civilization. Home to as many as 20,000 men, women, and children. On Santorini today, archaeologists are excavating an ancient Minoan city. Parts of the island have been buried under 100 feet of hardened ash.
You find all that murals and artwork, no bodies. The fact that there's no bodies makes us think that they knew that there was an eruption coming and they evacuated.
Generally, a large explosive eruption like the one that occurred at Santorini won't come out of the blue. There will be an increase in earthquake activity and an increase in kind of the thermal output of the volcano, which may be in the form of hot springs or fumaroles. And so it's likely that the Minoans noticed that the volcano was waking up.
The first sign might have been huge bubbles coming up from the 1,000-foot depths of the caldera, turning their busy seaport into a death trap.
In an extreme case, if you had enough gas in the water, there's a significant danger to vessels passing overhead because the buoyancy of the vehicle could be compromised by the creation of gas, either from the magma itself or from the seawater flashing the steam.
Submarine volcanic eruptions are also known to produce sulfuric acid and deadly concentrations of carbon dioxide. Minoans trying to escape by boat must have found hot, noxious fumes roiling up from the water around them. When the full explosion finally hits, it strikes both above and below the water.
The Minoan eruption of Santorini is colossal. It is now considered to be the second largest volcanic eruption in recorded history.
The force of the eruption is 40 times greater than the atomic blast at Hiroshima. As the island collapses, an underwater avalanche kicks up a wall of water, a tsunami.
The size of the wave is about 200 feet, the crest of the wave above the water level, and as much as 150 feet below the water level.
The wave moves at 150 miles per hour, easily overtaking any boat trying to sail away.
They had one chance to surf this huge wave for several kilometers. Some of them might have survived.
But even those who make it all the way to the main Minoan capital on the island of Crete are not safe.
It was the beginning of the end of their civilization because the society could not recover.
After the eruption, all that remains of bustling Santorini are island fragments. Many scholars believe that when Plato wrote of the sunken civilization of Atlantis, he was describing the Minoans who died on Santorini.
The most plausible connection to the theory of Atlantis is the Minoan race.
One civilization destroyed by a volcano born in the sea. Could it happen again?
Oh yeah, Santorini is absolutely still active.
In the Aegean, in the center of this ring of islands, 1,000 feet under the water, the volcano is gathering strength. It's just a matter of time, some experts say less than 100 years, before it wreaks havoc again. When underwater volcanoes reach up from the depths to sow death and destruction on land, they usually give some hint as to the impending doom. That there is another killer lurking beneath the surface in our underwater universe that is devilishly unpredictable. Giant whirlpools have haunted the dreams of sailors since ancient times. Powerful, inescapable, appearing without warning to swallow whole ships. These monsters, called maelstroms, appear in legends across the planet. But giant whirlpools are real and dangerous. In the North Atlantic Ocean, near the coast of Maine, is the 6th of the 7 deadly seas. Here you'll find some of the world's most extreme tides, pulling trillions of tons of water up more than 50 feet into rocky harbors. Sometimes, a serial killer emerges from the depths. The locals call her Old Sow. She gets her name from the sound she makes when she's active, like a hungry pig sucking down food, or in this case, human lives.
It's not unusual when someone gets lost in the water here to either not find the body at all or for it to take several days to find.
She has claimed at least a dozen victims over the years. Some days, there are only tiny whirlpools, known as piglets. On other days, Old Sow herself appears, usually 10 to 15 feet across, but she's been observed to grow 250 feet wide.
It doesn't look too bad, and then all of a sudden, boom, and we've actually heard accounts of people going along their boat, and suddenly a 12-foot hole opens up.
I was 17, and it was in the summertime when I was going to go fishing up to one of my favorite spots, up to Kennel's Head.
To get to Kennel's Head from Eastport, you gotta go past the spot where Old Sow lurks.
Whether it was there, whether it wasn't there, whether it was acting up, you never really knew.
As he passes Deer Island Point, he can hear a noise even louder than his 12-horsepower motor.
Kind of a whooshing and whirring noise, and that's when I approached it closer and found out that it was opening up. I was no more than 12 feet away from actually looking down into the throat of Old Sow. You could almost feel the spray coming from the center out.
The idea of getting sucked into a whirlpool fills many people with horror. It is one of our earliest fears.
The most common vortex that we experience in everyday life is when the plug is pulled on a drain in a bathtub and the water is sucked down the drain. And when you see that funnel shape, you assume that the water is going down that drain and that you can be sucked into it and pulled down to the bottom of the ocean.
The whirlpool in your bathtub and Old Sow are both products of the same two physical processes. First, gravity. Heavier things sink below lighter things. In this demonstration with 2 plastic bottles, the water is falling because it's heavier than the air beneath it. When Old Sow opens up, it's not because water is changing places with air inside a drain. It's because dense salt water flowing in with the tides is sinking below lighter fresh water flowing out of rivers. But gravity alone doesn't create deadly whirlpools. You also need centrifugal force. The water has to spin violently.
If there was no rotation and you somehow made a hole in the water, the pressure gradient force would just push water into the hole and the hole would be gone. But since it's rotating, we have another force that keeps the hole open.
Often a water current bending around an underwater obstacle is enough to set the vortex in motion.
There's an underwater mountain about 119 feet below the surface, and this water hitting it is part of the reason that you get this big gyre.
Oceanographers at the University of Washington recreate the conditions of Old Sow inside their fluid dynamics lab.
What I'll do is place a few of these.
They drop dye next to a black underwater bump. The water tank is slowly spinning, mimicking the constant rotation of the Earth. This helps set the whirlpool in motion.
If you sweep the ocean across one of these mountains, it will concentrate its Earth spin and appear in the lee of that obstacle as a vortex. And it can be perilously dangerous if you're a navigator, if you're a kayaker, if you're a swimmer.
Once a liquid vortex forms, unseen factors can make it spin faster and faster, becoming more and more dangerous.
One way to turn an ordinary vortex into a dangerous whirlpool is the mechanism of vortex stretching. It's really the same mechanism that ice skaters use when starting their spin. They start with their arms and legs extended, and then they pull them into the body and rotate faster and faster. This occurs when the vortex moves over deeper water, and then the vortex is stretched and thinned and rotates much more rapidly.
In the case of Old Sow, the deep channel next to the underwater mountain helps stretch the vortex, making her spin at speeds of up to 16 miles per hour. Paul Critchley's 12-horsepower motor is not enough to overcome the whirlpool's power.
The engine started to really labor because I was going in the opposite direction of the way the water was going. It was like trying to go upstream. That's when everything got a lot more intense than I really had planned it to be.
The 6th Deadly Sea, between Canada and the state of Maine. Here, mysterious forces open up holes in the water, like a pit of quicksand that appears without warning.
The boat was shuddering, the engine started sputtering. So the adrenaline, needless to say, was really kicking in, and I just looking death right in the face that close.
17-year-old Paul Critchley believes he is moments away from being sucked into a deadly whirlpool. Oceanographers at the University of Washington dropped 2 objects, a heavy gray ball and a lightweight yellow ball, into a simulated whirlpool. What happens is surprising. The lighter object slides down to the center of the vortex, but the heavy one doesn't.
The object floating low in the water is going to be flung outward, and the boat floating high in the water is going to sink down to the center of the whirlpool. So a survival strategy, if you're floating in a whirlpool, would be to drop your anchor a bit and hope that it gets flung out and carries you with it up the hill and back home again.
Paul Critchley doesn't know the physics of whirlpools, but he does know how to coax extra power from his outboard motor.
When I grabbed the tank and held it straight in the air and let it gravity feed right to the engine and get my butt out of there. I escaped the jaws of death right there.
Stories like these only reinforce our fears of dangers real and imagined that lurk beneath the ocean's surface.
Oceans have always been shrouded in myth and mystery. You don't know what's out there beyond the horizon. Once you get into the ocean a little bit, it's a totally different world, pitch black world. So it's easy to say there are these monsters of the deep.
One such monster of the deep struck on the dark night of April 14, 1912. It is the size of 2 city blocks, although only a fraction is visible from the surface. The stealthy, roving menace ripped open the largest ship of the day, HMS Titanic, and sent it to the bottom of the sea with 1,500 people. The monster is made of water in its most unfriendly form, frozen solid, rock hard, and constantly moving. Now imagine an entire sea made out of this deadly material. The 7th deadly sea is the Beaufort Sea, at the southern edge of the Arctic Ocean. A sea of ice most of the year, a frozen trap just waiting for foolish humans.
Many explorers have found that out the hard way. You know, they would bring their ship up there, get locked into the ice, and then hopefully circulate around, and then make their way to the North Pole and back. If they didn't get that calculation exactly right, it's not very good.
The Beaufort Sea is part of a vast frozen wasteland, an ice cap that has hidden the top of our planet for at least 700,000 years.
What we're looking at here is pack ice in the Arctic at the height of summer. At this time, about 3.4 million square miles is covered in ice, about the same size as continental USA. By midwinter, that pack ice has doubled in area.
Seen from above, it is barren and white. Seen from below, it is a hard shell atop a frigid polar ocean. A complex food chain has evolved in water that rarely gets above 32 degrees Fahrenheit. Without protective underwater clothing, a human would suffer crippling hypothermia within minutes. Even in summer, this water is deadly cold. But as the days get longer, the ice cap melts. That summer thaw has lured some of our greatest explorers to their deaths over the last 500 years. Starting in 1498, Europeans began looking for a way up and over the American continent, a northwest passage to China. But very few make it out alive. They underestimate the dangers of this shifting, unpredictable sea of ice.
Smacking into a solid piece of ice at a ship that, even at the slowest speeds, can cause major damage. Operating a ship in cold makes steel and material more brittle. Cold, hard ice, brittle steel, damage, ship sinking, loss of life. It's not good stuff.
Only 110 ships, most of them icebreakers, have survived the journey between the Beaufort Sea and the Atlantic Ocean. But that doesn't stop smaller vessels from trying. In July 2003, a 3-person crew, including father and son Richard and Andrew Wood, attempt the impossible in a 42-foot yacht. If they succeed, theirs will be the first British vessel of any size to sail the Northwest Passage in one season. The plan is Andrew's idea. He shares it with his father, a veteran sailor.
His immediate reaction was to just call me a complete and utter lunatic, and you know, how could anybody ever possibly sort of just go and attempt the Northwest Passage?
The lure of Arctic adventure calls another crew the same year. A slightly larger sailboat manned by a French crew is planning to make the same voyage. As the 2 boats head east through the Beaufort Sea, the weather couldn't be more calm. But this good weather brings an unsuspected danger. The water surface is smooth and the temperatures are low. A perfect recipe for a new layer of fresh ice.
It's difficult to know where you're going to get an accumulation of ice and where it's going to move, where it's going to melt.
Under the right conditions, miles of open Arctic Ocean can become covered in rock-hard ice in minutes. The 3 French sailors get in trouble first.
That ice comes in against the ship's sides, pushes against it, pops it just like a balloon.
miles and miles and miles of ice just pushing on like a crowd surge. There's no vessel that can really stand up to that.
Unlike the English boat, the French boat is wide in the beam. Her rounded keel reaches only 4 feet underwater. She is designed for a situation like this. The ice pushes up under their boat, pinching her higher, until she is out of the water completely. But the English crew knows that if it were to happen to them, they would be crushed in a matter of minutes.
So as soon as the boat is destroyed, then you've really lost everything.
They sail east as fast as they can, chase the entire 900 miles by enemy number 1, ice. Water in its solid state. The only substance that not only gets harder as it grows colder, but also bigger and lighter. The reason is hidden in the water molecule itself. 2 atoms of hydrogen attached to 1 atom of oxygen. As temperatures drop, strong bonds form between neighboring hydrogen atoms. Molecules line up into a lattice.
You can think of that the oxygen atoms are each one of these blue spots here on this ball. But as ice freezes, then these hydrogen bonds between those individual oxygen atoms starts to lengthen and you actually grow more space. And this is why water is less dense in its solid form than in its liquid form.
Because ice is less dense than water, it floats. But it can also be shockingly sturdy and sharp.
Ice against steel on a ship causes shivers down the spine.
Some days the ice disappears as quickly as it comes. The French crew is not only released from their frozen trap, they manage to catch up with the English. But in early September, both crews are trapped again in the harbor of a small island surrounded by ice in all directions.
We were preparing really for the worst, which was to be spending the winter in the Arctic with sub-zero temperatures, very little food and heating and all the rest of it.
Their only chance comes in an unlikely form, a massive storm approaching from the east.
It was our only chance of getting out of the Northwest Passage.
With luck, the high winds will blow the ice out of their path.
We had to take advantage of that situation as soon as we could.
The 2 boats set sail with Arctic wind blowing 50 miles an hour.
Ice rolling around and huge seas, freezing spray, freezing all over you. At this point, you know, it was so cold I couldn't feel my hands at all.
It's like trying to sail through a blender full of ice cubes. Only these ice cubes are as big as cars. In 2003, 2 yachts under 50 feet long set out to conquer the fabled Northwest Passage, where so many others have failed. 6 weeks later, they are 400 miles into their journey. Supercooled water is washing over the decks and rigging, instantly encasing everything in a hard, heavy shell.
Every bit of spray that's hitting you is freezing on your clothes. We had sheets of ice all over us. It was so cold I couldn't feel my hands at all.
Many ships have been lost in similar conditions, destabilized by the added weight of the ice. As the 2 boats get closer to the Atlantic Ocean, a new danger appears. Icebergs. Not the relatively thin ice that forms on the surface of the ocean. Massive icebergs are formed on land. Glaciers can grow up to 6,000 feet tall.
They're made of compacted snow. Pieces of ice start to break off. These icebergs calve off. It's not like a nice smooth piece that breaks off. They're very jagged. And so it's actually a really rough surface. It can almost be like a razor blade that then comes along the side of a ship and just sort of tears the ship open.
The English and French sailboats are tiny by comparison to these massive floating death traps.
big seas and freezing spray and icebergs smashing into the hull all the time, which is not just a danger for the hull, but it's also a real danger. If one of the icebergs grabs hold of the anchor chain, it can literally just drag the chain along and you along with it.
The last 100 miles of the 900-mile voyage are the hardest.
So we finally got to the Bellot Strait.
Against all odds, the two sailboats make it safely out of the Northwest Passage.
At that point, it was one of the joyous moments for us all because we were immensely relieved after all this pressure of days of going through storms. We were actually the first British vessel ever to return back to British waters via the Northwest Passage.
Whether more boats will soon be sailing the Northwest Passage remains to be seen, because the underwater universe at the top of the world is undergoing momentous change. The water is getting warmer, and the ice cap shrinks more and more each year.
We're actually not melting just the marginal sea areas away, but we're now starting to penetrate into the Central Arctic Ocean, which is in regions where we've never seen ice loss before.
The Beaufort Sea is more open to shipping than ever before in human history, but that doesn't mean sailing in these waters is safer.
In some ways, having it thinner might make it more dangerous because thinner ice is more easily moved around by the waves and the wind. And that actually might pose a more significant shipping hazard than the ice that's currently there right now.
The ice cap is not merely melting away, it's collapsing. In the summer of 2008, a glacier the size of Manhattan broke off of Canada's Ellesmere Island and fell into the sea. It was 4,500 years old as Stonehenge. But it is one of many massive ice shelves to disappear recently. Ever since the first humans appeared on Earth 250,000 years ago, we have been at the mercy of the seas. But most scientists agree that human activity is now responsible for planetary warming. And as a result, the 7 deadly seas are about to get even deadlier. We are making the oceans angry. As the ice caps melt and glaciers fall, the height of the ocean could go up more than 3 feet in the next 90 years. Some 600 million people living in low-lying areas will face increased flooding.
As the sea level increases, the penetration inland of tsunamis in many areas will increase. So the impact of future tsunamis might be much higher in terms of death toll than we have seen in the past.
Some meteorologists also predict more intense hurricanes and storm surges in our future. An increase of just 1 degree in ocean temperature means more fuel to feed killer storms.
Climate's about 2 things. It's about temperature and it's about precipitation. How hot is it? How cold is it? Is it going to rain? Is it not going to rain? How much? How little? The oceans control both of those things.
Climate is not the only thing changing. The actual chemistry of the underwater universe is being transformed by human activity. The world's oceans absorb carbon dioxide from the air and pesticides from the land with deadly consequences.
The yellow indicates human impact in the middle of the Pacific Ocean. As we move around the planet, we can see red indicating intense impact. Over 40% of the oceans are regarded as heavily influenced by humans.
I can take you down and we will see a piece of the planet humans have never seen before. And I'm pretty guarantee you'll see a beer can. Trash everywhere.
No one is certain how the underwater universe will affect the Earth in the future. What is certain is that we'd better find out.
The less prepared will be destroyed, and they will not be able to recover very quickly, and chances are they will not survive.
We, at our own peril, do not understand the urgency of exploring the oceans. By not doing research, we are risking surprise.
We can't learn to manage the ocean wisely if we haven't explored it, if we don't know what's out there, if we don't